People new to the broad topic of artificial intelligence often find themselves confused by the overlapping concepts of AI, machine learning, deep learning, natural language processing, and large language models. Let's break these technologies down and explore how they're connected using this diagram. In the previous video, we discussed how machine learning is one of the key approaches to solving AI problems. But where does deep learning fit into the picture? While machine learning gave us the tools to train models to recognize patterns and relationships within data, such as identifying objects in images or predicting house prices. Deep learning takes this to the next level by mimicking the way the human brain processes information. It's not just about learning patterns, it's about discovering complex hierarchical relationships in data, enabling machines to handle tasks like understanding human speech, recognizing faces, and even composing music. Deep learning, a subset of machine learning, operates on a structure called neural networks, which are inspired by the human brain. These networks consist of multiple layers, each layer processing data more deeply and abstractly than the last. This progressively layered structure is what allows deep learning to excel at tasks involving unstructured data like images, audio, and text. Deep learning is the foundation that powers natural language processing, a field focused on teaching machines to understand and generate human language. NLP is a crucial facet of AI that enables machines to interact using human language. Without deep learning, modern NLP systems wouldn't be as effective or scalable as they are today. Traditional NLP used rule-based systems to process language, but this approach had limitations. It couldn't handle the complexity, ambiguity, and nuances of natural language. Using deep learning changed the game. With deep learning, today's NLP systems can do a lot. They can understand context and meaning, generate natural, flowing responses, and even translate languages with impressive accuracy. Tasks like sentiment analysis, machine translation, as well as applications like chatbots are all possible because of deep learning's ability to process text data in ways that resemble human understanding. This brings us to the crown jewels of NLP, large language models. These models, like GPT or BERT, are built using advanced deep learning architectures. They are trained on massive data sets containing billions or even trillions of words, enabling them to understand and generate language at an unprecedented level of sophistication. Here's how it all comes together. Deep learning handles the heavy lifting, processing huge amounts of data and finding patterns. On top of that, NLP gives machines the tools to understand and use human language. Put those two together and you get large language models which can do everything from answering questions and writing essays to creating content and even translating languages. LLMs represent the peak of what deep learning and NLP can achieve together. Their ability to handle language in a nuanced and flexible manner has revolutionized industries from healthcare and finance to customer support and education. Let's explore an example that clearly illustrates the application of the concepts we've discussed previously. Imagine you're part of a rapidly growing tech company. Every day, your support team receives a huge number of user questions. Some are simple, like, how do I reset my password? Others are more complicated, like, what's the warranty policy? The number of questions is so large that it's overwhelming, and your team is struggling to keep up. It's clear. You need a solution. A chatbot could handle these queries, freeing your team to focus on more complex tasks. But like any remarkable innovation, your chatbot isn't extraordinary from the start. Its journey is one of gradual evolution, driven by learning and adaptation. You begin with a simple approach. Using a list of common questions and their corresponding answers, you build a rule-based expert system. When someone asks, how do I reset my password? The chatbot consults its predefined rulebook and delivers the correct response. It's efficient, reliable, and significantly eases the burden on your support team. You celebrate this initial success. But soon, issues arise. A user asks, I'm locked out. How can I get back in? The chatbot is stumped. It wasn't programmed to recognize this type of question. You quickly realize its limitations. It can only handle exact matches to what's in its rulebook and lacks the ability to learn or adapt over time. The verdict is clear. your chatbot needs to evolve. To make it smarter, you introduce machine learning. No longer confined by a rigid rulebook, the chatbot begins learning from past interactions. Now, when users say, "Can you help me reset my password?" or "I forgot my password," the chatbot identifies these as variations of the same issue. With the power of natural language processing, it recognizes patterns in language, understanding intent rather than just matching exact phrases. It's not just following rules anymore, it's learning. The results are encouraging. Users are happier and the chatbot handles a broader range of queries. But limitations persist. It struggles with complex or nuanced questions and doesn't fully understand what users mean. You sense untapped potential. So, you take the next step, integrating deep learning. With neural networks, the chatbot processes language with greater sophistication and contextual awareness, akin to giving it a brain upgrade. One day, a frustrated user types, "I can't log in and I've already tried everything." The chatbot doesn't just understand the request, it detects the underlying emotion, frustration. Instead of a generic response, it offers empathy. "I'm sorry you're having trouble. Let's tackle this step together." It even recalls the context of previous interactions, making multi-step problem-solving seamless. The chatbot is no longer just a tool, it's becoming a companion. Yet, as users push its limits with open-ended and highly specific questions, you realize there's more room to grow. Finally, you unlock the potential of a large language model like GPT-4, Google Bard, Lambda, Meta's Llama, etc. The chatbots transform into a conversational powerhouse. Trained on vast data sets, they can handle almost any question with ease. When a user asks, "Why should I choose your product over others?" the chatbot doesn't just list features. It crafts a thoughtful, personalized response. Our product stands out with unique features like X and Y, making it ideal for a specific use case. Customers also praise our exceptional support team. It's not just transactional. It can engage in open-ended conversations, tell stories, or simplify complex topics. The chatbot feels human. Of course, you remain mindful of its limitations. It might occasionally provide a confident but incorrect answer or misinterpret context. Safeguards are in place, and while the journey isn't over, the chatbot has revolutionized your support process. In this video, we examined how deep learning represents the next level of advancement in comparison to machine learning. While machine learning involves systems learning from data to identify patterns and making predictions, deep learning builds upon this foundation, enabling more sophisticated tasks like understanding language, recognizing faces, and even composing music. As the driving force behind modern natural language processing, deep learning facilitates innovations like real-time language translation, intelligent chatbots, and realistic AI-driven conversations. It is the technology that transforms AI from merely functional to genuinely revolutionary.